Welcome grade 11s. Today we are going to be looking at trigonometry and more specifically the area rule, the sine rule and cos rule. We'll be looking at the formulae that you need to know and how to apply these and the concepts that are involved. And we will then move on towards two-dimensional trig and show you how these formulae and concepts are applied there. So let's begin by having a look at the overview. Your key concepts here are, of course, as said, the sine rule, the cos rule, and the area rule. Just to bring to your attention, there are a couple of things that I would like you to remember before we begin. Ensure that you have gone to go and revise Pythagoras, the theorem of Pythagoras. Remember that Pythagoras can only be used in triangles that have a 90-degree angle. So in any right-angled triangle, we are able to use Pythagoras. The other concept that you need to keep in mind and cannot forget are your trig ratios. Remember that again, the trig ratios can only be used in right-angled triangles. And the reason I want you to keep these two concepts in mind is often you are going to be faced with a diagram that has more than one triangle. Some of them may be right angles and others will be your obtuse or scalene triangles. And you've got to remember to use Pythagoras and the trig ratios because often we need to solve for the angles and sides using these two concepts before we can move on and implement the sine, area, or cosine rule. So just be aware of that. And the last thing I need you to remember, and some of you may go, oh, is your properties of your triangles. And I just want to go into a little bit more detail here because you need to understand the properties and some of your geometric rules and theorems that you covered in probably grade 8 and grade 9. If you're doing paper 3, these will be more familiar. But if you're not, we just need to quickly revise this so that you are able to use these. So of course, the first one, which is really simple, is the three angles in a triangle always add up to 180 degrees, and you should be fairly familiar with that. Other theorem I'd like to discuss with you is exterior angle of a triangle. Exterior meaning, of course, outside. All right, so let's have a look here, and I just want to change the color. This over here is your exterior angle of the triangle. And this specific angle is equal to the sum of the opposite interior angles. For example, if this were to be 20 degrees and this one to be 30 degrees, this exterior angle would now have a value of 50 degrees. Okay, these are numbers that of course I'm just making up because you can see that this angle is greater than 90 and 50 degrees is acute. But so just so that you understand that concept. Also, I'd like you to remember things such as vertically opposite angles. Let's make that a circle. Vertically opposite angles are equal, all right? And these are certain concepts that you can use. Also remember all your conditions with parallel lines, that you've got corresponding angles, co-interior angles, and alternate angles. Because often these do come into these two-dimensional questions, and you need to know how to work with that. So if you're feeling a little bit uncomfortable with this kind of concept, just revise this in preparation for this section. Okay, let's now begin looking at our sine rule. get our color here, right? Solving two-dimensional problems using the sine rule specifically. Now this is very important over here. We need to know when it can be used. Because what is going to happen is you will be given a two-dimensional question, but you will not be told which of the rules to use. Now, we're not leaving you completely in the dark, because what will happen is the questions will have clues and it will have information. And dependent on what you've been given will depend on whether you use the sine rule, the cos rule, or the area rule. When you use your sine rule, you need to ensure that you have more than one angle and a side, or you need to have two sides and an angle. This angle cannot be included. What I mean by this, let's actually draw a diagram, because I think that'll be the easiest way for me to explain. If I give you this side of the triangle and tell you it's 3 units, and then I tell you that this side is 2 units, and I give you this angle over here to be 45 degrees. This would be an example where 2 sides are given and an angle, and it's not included. The included angle would be over here, and the reason why we call it included is it's between the 2 sides that have been given. So in case you didn't understand what we meant by included and not included, I hope that clarifies that. So now we know when we need to use our sine rule, when more than one angle is given and one side, or 2 sides and an angle. I would highly recommend that you memorize that, learn it, know that if you've got that information, if the information is given in the question, then you are able to use the sine rule to solve for the unknown, or solve for whatever side or angle you are being asked to find. Let's just have a look at our formula, which is sine A over A is equal to sine B over B, which is equal to sine C over C. And I'm just going to choose a different color so that we can have a look here. I want to draw another triangle here for us. And I'm going to label that A, B, and C. Now, having a look at our formula, you'll remember that your trig ratio, that this letter over here always represents the angle. That means sine A, we are talking about this point over here. The little a, this is the way in which we name our triangle. So capital letters A, B, C represent the vertex. All right, the vertices of your triangles. And the little letters are always found opposite, all right? The little letters represent the size of a side, and it is opposite the angle. So this is angle A. Opposite to angle A, we have side A, little a. Here is angle B. So this side, because it's opposite angle B, will be named little b. And similarly, angle C, this over here will be labeled as side little c because it's opposite that. So can you see here that this side, we can actually name the side in 2 ways. We can either call this side AB, or you can call this C. And it's important that you understand the notation here, otherwise it can become quite difficult to substitute into the formulae that you have for the sine, area, and cosine rule. Okay, let's now move along to our cosine rule. And again, I'm going to underline, and I'm going to keep to the same color so that we keep some sort of color coding here. We need to know when are we going to use our cos rule. And this, again, is going to be dependent on the information. So you are going to use your cos rule if 3 sides are given, or, and perhaps I should write that there so that you don't get confused and think you need both conditions, or you need to be given 2 sides and an included angle. And just to go back up here and revise that, that means over here this is your included angle, and if you were given that angle and the sides, we could use the cos rule over there. I hope this is becoming a lot more clear for you. And this over here, let's move to our orange. This again is now your formulae that you will use for your cosine rule. There's a few things I just want to show you here, and going back to this triangle over here. So if you're looking at your standard triangle of ABC, the formula says a squared. Remember, little a represents a side. A squared is equivalent to b squared plus c squared minus 2bc of cos A. And that, of course, is your included angle. Let's have a look if they ask you to find side B. This would mean they want this as the unknown. This is what we need to calculate. But your formula, the subject of the formula is a squared. So let's have a look at what we would do. The same way you would begin with b squared is equal to c squared plus a squared minus 2c multiplied by a cos, all right, because we're following the formula. But now if you have a look, which is the angle that is opposite side B, which we're trying to find? It is angle B. So this is now cos B. Ensure that you write that as your capital, all right, because that means that you are the angle. Am I going off the screen there? Yeah. Should I start from the beginning, Lizelle? So just...
Okay, cool. Thank you. So I'll stay on the board. So start with writing your b squared again.
Okay.
And action.
So b squared is what we want to find. So we make him the subject of the formula. And this is now going to be equal to this side squared plus that side squared. So we write c squared plus a squared minus 2c multiplied by a cos capital B, because that is, of course, the angle. And if you have a look, we're looking at the angle which is opposite the side we want to calculate. And if you take special note that this angle is included, it is between side C and A. And that is the way in which you can change the formulae. So you don't only have to work, if you're working with this and they've given that side, it doesn't mean that that's the only side you can use. So learn how to manipulate this formula. Let's have a look now at our area rule. And let's turn to green so we can highlight what information we need in order to use this. The area of any triangle can be found when at least two sides and an included angle. So we're kind of missing an and over here, so I'll quickly include that. Two sides and an included angle are known. This over here, we can also use not only if sides and angles are given. If you are given the area of the triangle, you can then work out either one of the given sides or one of the angles by substituting and manipulating the equation. So let's have a look and see. If I'm given the area and they ask you to find angle C, if you've got the side A and side B as well as what the actual area is, by substituting into that, C will be your unknown, and you can then solve that equation. So as well as having two sides and an included angle, you use the area rule, but also if you are given, so I'm going to put your plus, if you are given the area. Okay, So those are our three formulae. I hope you've had a chance to write them down. You don't need to know them off by heart. These formulae you will find on your formula sheet, but you will become so accustomed to them because you work with them, you write them down so often that you will automatically just learn them. So that's always something more comforting, knowing that you've got that. But if you panic and you can't remember, it's on your formula sheet, so not to worry. Let's move along. Okay, now that we know all our theory, now let's get to the exciting part, which actually involves working out a question. Question 1, there is a very specific instruction here, so I'm going to underline it so we've got that. It says round off your answer to 2 decimal places. Be very careful with this. You have to follow the instructions that you are given. If you are asked to round off to 1 decimal place, then you need to do that, okay? Also, be aware that at the beginning of your paper, be it a test or an exam, you are always given instructions. If your instructions at the beginning say round off to 2 decimal places, that instruction of course applies to your entire paper. But within certain questions, they can then change that and say specifically for this question, round off to the nearest unit or to 1 decimal place. You do need to follow those instructions, because if you don't, you can lose a mark for your final answer, which is a pity. If you do all the working out correctly and everything is correct, you don't want to lose that last mark because of a silly mistake and not listening to the instruction. Right, let's begin. Determine x. Now, before we begin, we need to look at this and ask ourselves, x. Is x an angle or is it a side? Having a look at the diagram, it's clear that x is a side. We have a triangle here, ABC. We've been given 2 angles and 1 side. And now I want you to think, okay, I've got 2 angles, 1 side. Am I using my area rule, sine rule, or cos rule? Well, we can't use the area rule because we haven't been given the area and we don't have 2 sides and an angle. What about our cosine rule? What do we need if we're going to use that? We need 2 sides and an included angle. We've only got 1 side. And what about our sine rule? Sine rule says if you want to use that equation, you need to have 1 side and 2 angles, or you need 2 sides and 1 angle that is not included. So hopefully, I hope you're looking at this diagram going, oh, I know exactly what to do already. It's my sine rule. So let's begin. We would start with this question, and because, helps if we've got the pen the right way around, because we want to find the side, I'm going to start with my side at the top. So this is now going to be x over sine 135 degrees, because 135 is what is the angle that's opposite to this side. Is equal, now I have my next side. Because x is a side on this side, we need to have our side as well. And of course, we've only been given 16, so we know we need to work with this. So we're going to say 16 over sine, and the angle that is opposite this side is A. And some of you might be going, well, I can't do this because I don't have that angle. I was only given 2 angles. But I hope you remember I said to you, you need to know your properties of triangles, which means if you've got 2 angles, you can work out the third. Because we know that angles in a triangle add up to 180. So to work out angle A, we simply say 180 degrees minus 135 minus 24, and we get a value of 21 degrees. And I'm going to go now and fill that in on the diagram immediately. Make that a dot. Oh no, that's not working nicely at all. It's just I want to have my degrees there. So this is 21, and I'll put my degrees on the outside. So that means now we're going to fill this in by saying sine 21. To continue, x is now going to be equal to sine 135 multiplied by the 16, because we've got it on this as a denominator. We want to make x the subject of the formula, so we would multiply, and I'm going to change the color so that you can see this. You would multiply this side by sine 135, and whatever we do to the one side.
Sorry, I can't see that sine 135.
Okay.
Can you try and make it a bit bigger, please?
Sure.
Okay, we can do a pickup there. And action.
We do this by multiplying both sides by sine 135. And whatever we do to one side of the equation, we do to the other. And what happens is that actually lands up cancelling with that, and that's why we're left with our x. So now we're doing a little bit of equations, doing a little bit of revision here. Sine 135 multiplied by 16, let me go back to my green, is going to be the same as 16 sine 135 degrees. And that is over sine 21. We now go and find the value of x by simply punching these values into our calculator. So let's do that now. Let's clear that. So at the top, we have 16 sine 135 over sine 21 degrees, and that is equal to 31,57. We were asked to round off to 2 decimal places, and there we go. So because the digit next to the 7 is a 0, we of course round down and it's just 31,57. Hope you got the same answer if you were doing that on your own as well. Get my pen back. And we finish this off by saying 31,57. And I generally like to finish it off by saying units. The reason why, whoops, so that looks like a T. The reason why I like to do that is often with two-dimensional questions, they will give you the units. They'll either tell you you're working in kilometers or meters or centimeters. So when you give the answer, you have to give the units. And when you're given a question like this one that we've just done, where there are no units, at the end you can just write units. And it just trains you to always question yourself, am I finding a side which would have units of centimeters, meters, kilometers, etc.? Or am I finding an angle which then you would know would be in degrees? Okay, let's move on to question 2. Not question 2, rather the second part to question 1. Okay, now we are introduced to a triangle MNP. And again, we are asked to round off our answer to 2 decimal places. And here we are asked to determine theta and alpha. So we go and identify that on our diagram. And here we have theta, and here we have alpha. The other information they've given us, so they've given us an angle of 19 degrees, and basically that means this over here has got a value of 19 degrees. They've given us 2 sides. They've told us that MN is 12,1 units, and that PN is 23,5 units. So what do we have here? We have 2 unknown angles. We've got a known angle of 19 degrees, and we've got 2 sides. The angle isn't included, and I hope you've automatically said it's the sine rule again, because I have 2 given sides and an angle, but it's not included. So let's begin and apply this. We'll start off by finding theta. Now here we are finding an angle which is different to the first part of question 1 where we were finding a side. Now we're looking at the angle. We could start off by saying sine theta over. Now notice that because we're finding the angle, now I have that on the top. And if you're not sure what I'm talking about, I'm just going to go back to the last slide. Here we were finding a side, so I put the side as my numerator, and my ratio with my angle was at the bottom. In this question, because we are finding an angle, I'm going to put that at the top. So we start with sine theta. The side that's opposite that is 23,5, and we substitute that, is equal to, and I could put sine alpha, but then I'm going to have two unknowns. So I know this now certainly needs to be used, and we're going to say sine 19 degrees over, and of course 12,1 is opposite, so we now write 12,1. We want sine theta on its own, so we now make this the subject of the formula, which is now going to be equal to 23,5 sine of 19 degrees over 12,1. We now go and find that value using our calculator. We'll clear our previous question. And we are going to have, let's just have a look what we've got. 23,5 sine 19. So 23,5 sine 19 over our 12,1. And we find our answer by getting 0,63. Now, I'm going to put this into my memory because I don't want to round off within the question so that my last part of the question isn't incorrect. So we can, when we write it out as our answer, we're going to round off, but I'm going to keep it in my memory because when I use it just now to go and say second function of sine, I want to put the entire value in. If we round off within the question, often the final answer is not always 100% accurate. And if you don't know how to use your memory function on your calculator, listen carefully. So what I've just done, you'll notice I pressed M plus, and you'll see it says answer M plus, which means the calculator has now stored this answer in its memory. And that's why this little M has appeared. It's now telling me that it's there. Okay, so we can clear that now. And we write sine theta is equal to 0,63. But this is not my final answer because I want to find the value of theta. Now, time to do a little bit more revision. Before this section, you would have covered all the other topics within trigonometry. You would have learned how to find a side using your trig ratios, and you would have learned how to find an angle, and by now you would have done trig equations as well. So we know when we're finding our angle, we have to use our shift function of our sine ratio in our calculator. And that's what I'm going to do now. So we pull up our calculator, and I'm saying shift, which gives me my second function sine. And I now want the answer that I've stored in the memory. So I'm going to press this button over here that says RCL, which stands for recall. What do I want to recall? I want to recall my memory. And now we simply press equals, and we found that theta is equal to 39,22. 39,22. But if we have a look at theta, it is clear that theta is an obtuse angle. And the answer we've just received, 39 comma 2, 2 is an acute angle. And I hope you remember from when you did trig equations that you've got two solutions. So we know that our next one is we would work out by saying 180 minus 39 comma 2, 2, which would give us an answer of 140 comma 78 degrees. And of course, this is definitely the answer, as this is an obtuse angle. We can see that this angle is greater than 90. Now let's have a look at angle alpha. This is the beauty of mathematics. There's always more than one way of calculating things. And with alpha, we could use more than one method. I want you to have a look at the question and see what would you do. How would you now go and solve for alpha? I hope you're not completely stuck and that you at least have one strategy of finding it. But let's have a look at the two ways in which we could do this. So we have alpha over here. We've just worked out theta, and one of the things I certainly like to do, and it's a good habit that you get into, is every time you find information and you've got an accompanying diagram, go add that information to it. Because often what you've found sometimes needs to be used in further questions. So this, I don't want to put it in there because it'll be too busy, but theta now is of course 140,78 degrees. And I hope you thought to yourself, well, there's a really easy and quick way of calculating alpha, and I would do that by saying alpha is equal to 180 degrees minus 140,78 minus 19 degrees, and that is because angles in a triangle add up to 180 degrees. Or you could go and use your cos formula here, because you've got the two sides and you've got the angle in the middle. Or you could use your sine rule here as well. But of course, by using those formulae, it's going to take a whole lot more time than just saying 180 minus the two angles you have in there. And I'm sure by now you've realized that when you're writing your maths exams, that time is definitely a limiting factor. So if there's an easier and quicker way of doing things, we certainly want to do it that way. So at the end, you could then just conclude by saying, and I'm going to write it on this side here, we have more space, that alpha is equal to 180 degrees minus 140,78 degrees minus 19. Calculating that, we can see that alpha is then going to be equal to 20,22 degrees. And that is what we have for alpha. Having a look at that, we can see it's clear that it's an acute angle, which should make you happy with your final answer. And in that way, we've completed part B of question 1. Let's have a look at what the third part of this question has to offer. So again, we are given now a different triangle. We've got triangle PQR. We've been given the side PQ, we've been given the side QR, and we've got an angle. Notice that that angle is included, and our unknown is x. And this happens to be a side. Our instruction is to round your answer off to 2 decimal places, and they tell you determine x. What formulae are you thinking of using? I hope you've seen and go, now we're going to have a look and practice our cosine rule, because we've got two sides and the angle is included. And this is a direct application of the formula, and we can begin. Let's change the color so that we keep things exciting. So I'm going to start with my side, which is going to be x squared. That's our subject of the formula, is going to be equal to PQ squared, and immediately I'm just going to substitute the values, 10 squared plus QR squared, 9,6 squared, minus 2 multiplied by the one side, which is 10, and the other one by 9,6, cos of the angle that's opposite the side that we want, which is going to be cos of Q, which happens to be 85 degrees. And I put that in there. And I recommend that instead of going to work this out separately and then 9,6 squared and that, I would recommend that you put this all into the calculator at once. It eliminates you from making careless errors in between, and that's what we're going to do now. So let's clear this. For those of you who are not familiar with your memory function, now that we've stored the memory, we've recalled it, but now that M is there, which means the answer we've been working with previously is stored into the calculator, and now I want to clear that. So listen carefully, this is the way in which we do it. We recall the memory, and above this button you'll see that your second function is M minus, so that means delete the memory. So we say shift M minus, and you see it's cleared, and you see now there is no longer little m at the top of the screen, and voila, it's gone. So now we can start with this question fresh. So we have 10 squared plus 9,6 squared minus 2 multiplied by 10, nope, by 10, 9,6, cos of our angle 85 degrees equals, and we get an answer of 175,42, and we're rounding off to 2 decimal places, so that'll be 43. And now we just simply write in our answer, and you have just found what the value of x squared is equal to. So we have x squared is equal to 175,43. I hope you're not putting your pencils down and thinking, well, there we go, that was easy enough, because the question asked us to determine x, and I have a value now of x squared. But this shouldn't be a problem for you. We have a look and we see, all right, this is x squared. I know the way in which to eliminate the square. I do the opposite, which is square root. And whatever I do to one side, I'm going to do to the other side to keep my equation balanced. And x is going to be equal to 13,24. And again, I'm going to write here units because we were asked to find a side. And just to have a look, the other thing I'd like to bring you to your attention, especially that the exams are just around the corner, this was a question that was for 3 marks. So let's have a look. Where do these 3 marks come from? Well, your first mark is coming from the fact that you used the correct formula, the cosine formula. The second rule, the second mark will come from substitution, so that you substituted the 10, the 9,6, and the angle correctly. And then the third mark is, of course, for your final answer. And it's as easy as that. So if you are, let's say, for example, you've used the correct formula, but you've substituted incorrectly, you would still get 1 out of 3. You'd get the 1 mark for using the correct rule, but you wouldn't get the rest of the marks because your answer would be wrong and your substitution is incorrect. So keep that in mind. Of course, you're not going for 1 out of 3. You want to get 3 out of 3. So be aware of these little things. Let's move on to our next question. Okay, now things are getting a little more exciting. If we look at our diagram, we've got a quadrilateral here, PQRS, and we are told to refer to the diagram and then calculate. Before I even look at the questions, let's have a look at all the information that is given. And I think this is a really important technique to do, that when you have a diagram, always ensure that whatever's in the written question, that is in the diagram. If it isn't, if there's something that's left out, you must include it. And critically look at the diagram. Ask yourself, what do I have here? How many triangles do I have? What shape do I have? Are there any 90 degrees where I would be using Pythagoras or my trig ratios? So that is what I want you to be going through in your mind while looking at the question, even before you look at what you have to calculate. So let's do that now together. so that you get an idea of what it is that I want you to have a look at. So this is a quadrilateral because we've got 4 sides. We have a 90-degree angle, which could be important. I have 2 triangles. I have triangle PRS and I've got triangle PQR. I have been given the length of PS, the length of SR, the length of PR, and the length of QR. And I don't have that angle or this one, or that one, or this one. So I've been given lots of sides. I've been given one angle, which we told this is 90 degrees, but I don't know what this angle here specifically is in that. I don't know how that is divided. So not too much information in terms of angles. So now let's have a look at what they want us to do. So the first thing, they want us to find PRS. In other words, this is what they want us to find, this little piece over here. Okay? Because we're looking at PRS, we are most likely working in triangle PRS. So I'm going to highlight this now in green so that we know that this is what we are focusing on now. And what information do I have here? I have been given 3 sides and I want to find the angle, which happens to be an included angle between the 2 sides that I've been given. Now what? What formula are you going to use? Are you using the area rule, cosine rule, or the sine rule? Which one are you going to use? Now I hope you're looking at that and saying, all right, well, I can't use my sine rule because for my sine rule I need to be given 2 sides and an angle. I don't have that, that's what we've got to find. Or I need to be given 2 sides and an angle that isn't included. Don't have that. And there you can see, well, I'm not going to have enough information. I'm going to have more than unknown. So now, by process of elimination, we go to the next one. What about the cosine rule? Well, cosine says we need 2 sides and an angle. Well, I've got 3 here, but what we want is in the middle. So can you see here that here, what's actually unknown is the angle, and you can use your cos rule. So this is the next step in terms of the application that we're going to do. If you're feeling a little bit uneasy, then listen up carefully and let's do this together step by step so that you can be nice and comfortable by the end of this question. We're going to begin by using, because this is our unknown angle, this we would work with our opposite side, which is going to be PS. So we would begin here by saying 52 squared is equal to PR, which is 73 squared, plus SR, 60 squared, minus 2 multiplied by the 73, multiplied by the 60, and then cos of my angle, which is going to be R, and that, of course, is my unknown. And what we do now is we just simply manipulate this question. And what we can do is we want to make cos R the subject of the formula. So we'll have 52 squared minus 73 squared minus 60 squared is equal to negative 2 multiplied by 73, 60, and cos R. And all I've done, simply what I've done is I've said I want to take my 73 squared and my 60 squared to the other side. And that's what I've done here. But I still don't have cos R on its own. And I've got minus 2 multiplied to 73 and 60, which is still multiplied to this cos R. So to eliminate that, we're going to divide by negative 2 multiplied by that. Okay, and as you can see, this will then, of course, cancel without leaving our cos R on its own. But remember, whatever we do to one side of an equation, we must do to the other side to keep it balanced. And just in these 2 steps, we now have cos R as the subject of the formula. And this is now what we would go and punch into the calculator to get our answer. And we're going to begin by doing that. So we pull up our dear friend here, and we put all of that in. We start by saying 52 squared minus 73 squared minus 60 squared over negative 2 multiplied by 73 multiplied by 60 equals. Convert that to our decimal. And again, I'm now going to use my memory function. So if you're still not feeling very comfortable with this function because you've never used it before of the calculator, have a look. Our answer is 0,7106164384. We now don't want to go and write that whole thing down. So clearly when we write our answer here, I'm going to round off the round. I'm going to write down the rounded off answer, which will be 0,71. But I need this full answer, so I want my calculator to store it in the memory, and I simply do that by pressing memory plus. Notice that it's clear at the top, and I press memory plus, and there you go, our little M appears. So we've got our answer in there, which I've now already forgotten, so let's just recall our memory, 0,71. So that's what we're going to put in here. 0,71 is equal to cos r. And again, we're going to you know how to do this. We're going to revise how to find the value of an angle. So we want r on its own. And that means we're going to have to say second function cos 0,71. And that's why I put the value into my memory, because I need that entire value. So now we start by saying second function cos, recall my memory, equals 44,71. 44,71 is equal to r. And now we go and look at our diagram and say, well, let's have a look. That's my r there. I just got a value of 44,71. Is this an acute angle? Indeed it is. And you've learned that with finding the equation, we always say second function cos, and you then would look at the quadrants and find where the angle is. And because this is positive, we're looking at quadrant 1, so we know that the angle is acute, and that would now be our final answer. Hope you're happy with that. So now you've gone to see how we can actually use the cos rule, not only to find a side, but to find the actual angle. If you feel more comfortable with that and you've had some more practice to use your memory key. Now let's have a look at our next question. Now that we've found the angle PRS, like I said in the previous question, I recommend that we go and fill the information in. So now on my diagram, I'm going to now write 44,71 degrees, because that's what we were asked to do in the last question, and we might need this information to do this next part. The second part is now asking us to find the area of triangle PQR. So if we have a look, PQR, we are now working in the next triangle. So I just want to use now a different color. So this now we are working in this triangle over here. Okay, that doesn't mean that we can't use the information from here, but just so that you know where we are looking. Now, this word area, hope you've all sat back and go, all right, now finally we're going to use our area rule and see how this works out. And of the two, it's probably the easiest one, because it's simply just substituting two values in an angle and it's done. So let's get straight into it and show you how easy it is. Okay, we've got our area of triangle PQR, and we can say, well, this is now equal to half, okay, the one side multiplied by the other side and cos of the angle. But before I go and do this, I'm going to look here and say, but wait a minute, I have a slight problem because for my area rule I've been told I need two sides and I need the angle that is included. And over here you'll have a look and say, okay, but wait a minute, that means I need this angle here. And just to use a different color to, we don't get that confused. Okay, I need this angle. I need to know what my angle PRQ is. PRQ. I need to know what that angle is. Are you stumped, or do you know how to solve that immediately? That little block that they have in the question, that's what I call hidden information. What is that telling you? Remember, we said it's a right angle. So we know by that block that they put there, which I've now covered with my colors, but that tells us it's 90 degrees. So if this little part here is 44,71 degrees, that means our angle PRQ is equal to 45,29 degrees. And we simply work that out by saying 90 minus 44,71. And now we can continue with our question because we no longer have a problem. So we say half of our side PR, which is 73, multiplied by side QR, which is 35, sine the angle which we find here, which is 45,29 degrees. And again, our calculator is going to do all the hard work, and we simply substitute. And again, watch what I'm doing. I'm just clearing the memory. And we now have a half. This is multiplied to 73 and 35. And sine of our angle of 45,29 degrees. And our answer is 907,889, etc. And this is our final answer, so we can round off. We were told at the beginning of the question to round off to 2 decimal places. So our final answer is going to be 907,89. And we just finish this off, of course, by writing that in. And it really is that simple. Again, I'm going to write my units, but now remember we've been asked to find our area, so this means it must be units squared. If we had been given what units this was, for example, let's say this was 73 centimeters and that was 35 centimeters, then your answer here would have been 907,89 centimeters squared. And your 4 marks for this question come in from, you would get your first mark for using the correct formula. Your second mark comes in from substituting correctly. The third mark you get for having to work out the angle PRQ. And your fourth mark, of course, is for the final answer. And that is how you apply the area rule. It's so simple. As long as you know what information you need to use the rules or the formulae and you know how to substitute, it's really that simple. Let's move on to our next question. Question 3 looks a whole lot more exciting, and we've got a little bit more information. There's a bit of a story at the top, so let's start off by reading that. A piece of land has the form of a quadrilateral. Okay, quadrilateral, quad. So for those of you who struggle with the English part of maths, just think of a quad bike. How many wheels does a quad bike have? 4. So a quadrilateral is a shape with 4 sides. So this is our 4-sided shape, A, B, C, D, with AB is equal to 20 meters. And this is what I mean by always ensure that the information they've given you in writing has been transferred to the diagram, because sometimes they put some of the information and not all of it. So ensure that everything is on the diagram. So what I mean is AB is equal to 20 meters, and we now go and look. AB is equal to 20 meters. We've got the value and the unit. So now we've finally got our units. BC is equal to 12 meters. CD is equal to 7. There we go. And AD is equal to 28. So that's at the bottom here, and that's been filled in for us as well. They tell us that angle B has got a value of 110 degrees. Now, the owner decides to divide the land into 2 plots by erecting a fence from A to C. So imagine that you've got an aerial shot of a piece of land, and this is what your land looks like. So let's give this farmer a name. So let's say Farmer Brown has got this land, and he's decided he doesn't want it all as one piece. He wants it as 2 pieces, and he's going to erect a fence. And they told us the fence was AC. So this over here is our fence, and I'm just going to put a color to it. And this fence, which is our line, okay, has now divided our quadrilateral into 2 triangles. And of course now we know, okay, great, now we're going to use our trig, and there's no right angle, so we can't use Pythagoras here or our basic ratio, so we know we need to use one of our 3 rules. So let's continue and see what we need to do now specifically. Calculate the length of the fence AC correct to 1 decimal place. Now they've changed this. Now they only want it to 1 decimal place. So they want the length of AC. So let's have a look at this triangle and say, okay, I can either work in triangle ABC, or I could work in triangle ACD, and we now need to choose which one. And we do need to choose. We can't work in either one in this case because of the information. And this is what I mean. If you look at triangle ACD, you've been given 2 sides. But we don't have the angle D, we don't have angle DCA, and we don't have angle DAC, and there's no ways of working those out. So now we move on to our second triangle and say, okay, well, let's hope we've got more information here, and indeed we do. We have a side CB, we have the side AB, and we've got an included angle. And as soon as I say included angle, I hope you're thinking Cosine Rule. And that's exactly what we're going to do. So let's begin. Our line is AC, so we're going to start with AC squared is equal to CB. Hopefully you've got the questions in front of you so that you can have a look. So this is now going to be 12 squared plus 20 squared minus 2, the 12, multiplied by 20, and cos of the angle that's opposite AC. And we've got that given angle, so that's now angle 110 degrees. And now that's just a matter of putting that all into the calculator again. $20 squared cos of our angle, which is 110 degrees, and we get our answer of 708,16. And I'm quickly going to store it into my memory in case I need it, and I now write my answer here of 708, what was that? Let's pull up the calculator again. 708,16, which is going to be 17 when we round, whoops, 17. Now remember, we've got AC squared, which means to get AC on its own. Okay.
To 1 decimal place, the question says. Does that make a difference?
No, it doesn't, because it's within the question. It's the final answer that must be 1 decimal place.
Sorry,
Yeah.
just checking.
No, and thank you for doing so. And I'm lost over here. Okay, there we go. Now, perfect, and it's given me a chance to get to where I'm supposed to be as well.
So just do a pickup for me. Will you just write your answer down again, please, if you don't mind? Your 708,17.
And thank you. I'm actually going to now say that because that's actually a point that some of the kids might be wondering. Thank you. Now answer is, of course, 708,17. And some of you might be thinking 2 decimal places. The question said correct to 1 decimal place. Remember that that's our answer. So here you can do that. We're not finished because that was AC squared. And of course, to get AC, we need to now square root both sides. So AC, and we put this into the calculator, and I'm now glad I've got that into my memory, because now I can say square root, recall my memory, equals, so the value is AC is equal to 26,6, and now I'll have to round off to 1 decimal place because this is my final answer. So AC is equal to 26,6, and now we have to put our meters in because they gave us our units. So now your final answer must also include our units. And when you do this, once you've got your final answer, make it a habit that you go and put this onto the diagram immediately so that you've got it, because the next part of this question might require you to use that information. Okay, let's have a look at the second part. The second part of this question asks us now to calculate the size of BAC. Now we're looking at an angle, BAC, and correct to the nearest degree. So lots of information here already. We know we need to calculate the size of an angle and very specific instruction to the nearest degree, and that would be the final answer. We still with Farmer Brown and his plot and fencing it off. We've already found the value of AC in our last question, which was 26,6 meters, and I'm just adding that in there in case we need that. And this now is BAC, so BAC. That means now they want us to calculate this angle over here. Okay. And having a look at this, there's quite a few ways in which we can tackle this question. We could use our cosine rule because we've got 2 sides and the included angle. The only thing that concerns me with doing that is in the exam, if you've made a careless error and you've got this question wrong from part 1, where you found the value of AC and this is incorrect, you of course now will get the angle incorrect because you're using the wrong values. But if you are 100% sure that what you've done is correct and you want to follow that way, you are most welcome to do so. But we have more than one option in this question because the triangle's got so much information. We've got the 2 sides and another angle that is included within that, but we've also got these now 2 sides, and we can use these 2 sides and the angle that isn't included. And with that, you can also use your sine formula for here. So that's what I'm going to do now. If you want at home, you can go and use the cosine rule, and you'll see that we're going to get exactly the same answers. So let's begin. Because we work out the angle, I'm going to put BAC at the top as my numerator. So this is now going to be sine of angle BAC over, and this is now going to be opposite this side. So remember, this is the angle we want, so now I've got to use the 12 meters. So this is going to be over 12, and this is now going to be equal to sine 110 over, and this, what's opposite that is of course our 26,6 meters that we've just found. Right, so I'm using these 2 and those 2 sides as well. Could we use the 20 meters in the sine formula where you don't have the corresponding angle then? Because you've only got one angle, you couldn't go calculate that angle with using your properties of a triangle. So now let's move along from here. We want to make this the subject of our formulas. So this is now sine BAC is equal to 12 sine of 110 degrees over 26,6. And of course, I'm not going to do it the long way all the time. You should know that I'm manipulating the equation and making the subject of the formula, and I have multiplied this fraction by 12, which cancels it, and I do the same to that side, and that's why it's up at the top there. Okay, if you don't understand that, you need to spend some time working on your equations. It's absolutely essential because it creeps up in all sections of maths. So make sure you're very comfortable with that. Continuing, we go and put this into the calculator. We have 12 sine 110 degrees, not 10. And notice what I'm doing there as well. Don't just punch into the calculator when you're working at school. Also look at the screen. Make sure that what you're punching in is displaying on the screen and that you haven't pressed the wrong button by mistake or lost a value, because your final answer is going to be wrong. So be careful of that as well. Watch the mistakes that I make as well, and make sure you don't make those as well. We learn from our mistakes. And of course, that's our 26.6 equals to 0,4239. And when I write this in here, I'm going to, within the question, I'm going to round it off, but I'm now putting that into my memory so that I can use the full answer in a short while. So sine BAC is now equal to 0,42, sorry. Now we want to find the angle. So again, we're now going to use our second function, and we will recall the memory to do that so we can use the entire value. So we start off by saying second function sine, recall our memory value that we've got, is equal to 25,08. And remember that the question asks us to round off to the nearest degree. That means to the nearest unit. So the final answer is actually going to be 25 degrees. And you put the units there, 25 degrees. Now notice over here I've said sine BAC is equal to, I can't keep these equal signs open because otherwise I'm saying that 25 degrees has the same value as 0,4, which has the same value as that. So here, this is now where we have to write BAC is equal to 25 degrees. The ratio has a value of 0,42, but the angle has a value of 25 degrees. And there we have it. We found our little angle there, and for 2 marks, because you are just really simply using the formula and doing substitution. So not too much. Not too many concepts involved there. You're using one formula, and it's simple application. Let's have a look at what we need to do next. Because we're on the same question, remember it's important to have the information. So we know that this is our 26,6 meters. I've just found that this is 25 degrees. And now over here it says to us, calculate the size of D. Because it's got our little hat on top, that means the angle. And again, it must be correct to the nearest degree. For 3 marks. And now for the first time, we are moving into this triangle ACD. And we are now asked to find an angle. In this triangle, we've got 2 sides. So what do you think we're going to do here? Are we going to use the sine rule or the cos rule or the area rule? What do you think? I don't want to keep giving you all the answers. I want you to sit there and think as well. What have you chosen? I hope you said the cos rule, because you've got 2 sides and the angle that we're finding is included. And those are the properties that we need in order to use the cos rule. If you didn't choose that one, Okay, go and write down the formula that you chose. So for example, if you decided you wanted to use your sine rule, write it down and start substituting, because immediately you will see that you're not going to have enough information to fill that out, and you're going to have more than one unknown, and then you can't solve for the angle. So it's sometimes important to see why what you've done is incorrect. So do that if you didn't choose the cos rule. Because I want to find angle D, that means my subject of the formula is going to be this side over here, AC. And again, we're going to be using that value. So I'm going to start off with 26, 6 squared is equal to 7 squared plus 28 squared minus 2 multiplied by 7 multiplied by 28. And that's going to be cos of the angle that I have, which is this one in the middle, and I'm going to call this cos D, and it's my unknown. And again, we're now going to have to make cos D the subject of the formula, and I'm going to go through this relatively quickly because we've already done an example like this. So we're going to have 26, 6 squared minus 7 squared minus 28 squared, and we're going to have that divided by negative 2, which is multiplied to the 7 and the 28, and that is equal to cos D. We put these values now into our calculator to get our answer, and we have 26.6 squared. And I hope you're not just sitting there watching me do this. I hope you've got your calculator out as well, and that you're following with me and doing this as well. Do the questions, don't just listen. Minus 28 squared. And we get an answer of 8 over 25, which we can put into a decimal, makes it easier to work with, and it's 0.32. So we have that cos D is equal to 0.32. Are we finished with the question? No, they didn't ask us to find the value of the trig ratio of cos D. They asked us to find the angle D. So now we need to go and work out the angle by saying second function cos, and now that's what we do in the calculator. So second function cos 0.32, and we get an answer of 71.33. And I'm going to write that down. 71.33 is equal to D. But remember, the question said correct to the nearest degree. And that's why it's also a good habit that whenever you write your final answer, not only for trig, any section of mathematics, every single question, when you've written your final answer and you've finished, always go back and read the actual question. I don't mean the entire thing, but the question that says calculate. So this, calculate the size of D correct to the nearest degree, which means now I must finish this off by saying D is equal to 71 degrees. And I have a look and go back at this and say, all right, is this an acute angle? Indeed it is, so I am happy with that. And of course, remember, if you're thinking of your quadrants, 0.32 is positive, which is in your first quadrant. And where else is cos positive? I hope you said in the fourth quadrant, but that would then be an obtuse angle or a negative angle. And that's not what we have here. So 71, we take it from our quadrant 1. And that is our angle there. I hope you're happy with this. And I hope we've helped Farmer Brown here with his divisions of his land. Let's have a look at our next question. Or rather the next part of question. Section part D rather. Calculate the area of the entire piece of land, A, B, C, D, correct to 1 decimal place. Again, we are being told where to round off. And of course, Farmer Brown obviously wants to now know what the value of his land is, and he needs to know the total area of it. So let's help him out with one last question. Area. Now, if we have a look here, we want the area of the entire piece of land. Do we have a formula to work out the area for a quadrilateral? No, but that shouldn't concern you because we've been working with these two triangles. So what we simply have to do is go and work out the area of triangle, triangle ABC and triangle ACD, which we've got quite a lot of information, and we work the area of those two, and that is, we just add the two areas together at the end. So I'm just going to add the information because I keep getting a new diagram when I work on the next question. So that was 71 degrees, and let's just have a look here. What was that? One was 25 degrees, just so that we have everything on one page. This is our 25 degrees. So now we need to work out the area of triangles. So let's start with the top one, the triangle of ABC. And the other thing I want to bring to your attention, when you've got a question like this, you're working out the area of the total shape, but you're going to be working in the two different triangles in the same question. Be careful that, and maybe not careful, but be considerate and notate your work nicely so that your marker can see exactly what it is that you're doing. And what I mean by that is area, don't just write area. What area are we going to look at? So the first one, let's do the area of triangle ABC. So here you're going to say area of triangle ABC equals. Now we know exactly what we're doing. We're working in triangle ABC, and it doesn't leave your marker guessing. What are we doing here? What's been calculated here? Because if you've done something incorrect, you might not get the method marks because the examiner or the marker doesn't know what it is that you're doing and where you're working. So be careful with that. It's these little tips that sometimes make a big difference. Let's continue with the question. Need to find our area. We are going to start off with half, and now let's have a look at the values we need to substitute. So for A, B, C, let's use half of 20, and then we're going to use our value of 12. Okay, so I'm using 20 and 12, which means then I'm going to have to use my included angle of 110 degrees. So sine 110 degrees, and I can work that out in that way. What I also want to show you is I can go do that, and then in the next one write area of triangle ACD, and then go add them up. And the reason why I did this is I want you to realize the way in which you could notate. But in one step, I'm going to now work out the area of the entire shape, and this is the way in which we can do that. So this is just to show you, and I'm just going to put it into a different color so that this doesn't confuse you. So this is an example of the way in which you can annotate and show your marker what triangle you're working in. And now I'm going to go back and show you how in one step you can do both. So we're going to say area of ABC. So I'm still writing the whole thing, but now what I'm going to do is what I've written here of the one triangle, and I'm going to add the second triangle into that immediately. You'll see what I mean now. Now I'm going to say plus half, and now I'm going to use the formula for this second for our triangle ACD. Hope you're following, which is going to be 7 meters multiplied by our 28, and this is the information that they've given us. So our 7 meters here and our 28, and that's why they got us to work out angle D, because we now need that to work out the area of sine 71 degrees. And now we just put this whole thing into the calculator. And again, I suggest that you put in the whole thing in one step into the calculator. Some of you have gotten into the habit of working out this first part and then putting a value in there and then saying plus and working out that second part and putting the answer there. Thing is, if you make a mistake in one of the steps, it can make the final answer incorrect, and also with the rounding off. So start getting used to doing that, and that's why I say do it. So have your calculator in your hand and do it so that you can ensure that you get to the same answer that I do. So let's do this together now. Again, just clear the memory. Whoops. Doesn't want to go away. There we go. So we have half 20 and multiplied by 12, and that was sine 110 degrees, plus our second one, which was 7 and 28 meters, and sine of 71 degrees, which was the angle we found, and then we just press equals and we get an area of 205,423. And remember, it said 1 decimal place, so that means our final answer is going to be 205,4. 205,4. They've given us units, meters, and its area, so it's meters squared. You must make sure that you put these units in, and that is your area of ABCD. Now Farmer Brown knows what the area of his entire land is, and I hope when you were doing it on the calculator that you got the same answer. If you didn't, pause and just go back and check exactly what it is. Maybe you've forgotten a bracket, maybe you've punched in the wrong number. Just be very cautious with that. Good luck, practice these, and most importantly, enjoy it while you're doing it.